Lesson 12.4 is on comparing sets of data. In this video, you will determine the effect that transformations of data have on measures of central tendency and variation, and compare data using measures of central tendency and variation. Okay, so vocabulary for this section is linear transformation. Okay, so we want to talk about transformations using addition. So if a real number, let's say k, is added to every value in a set of data, that means that the mean, the median, and the mode of the new data set can be found by adding k to the mean, median, mode of the original data set, and the range and the standard deviation will not change. So if I have a list of numbers and I want to find the mean, median, mean, median, mode, range, and standard deviation of the data set obtained after adding 12 to each value, I want to know what it does. So I'm going to show you guys a calculator that you guys can use at home to enter these values. Okay, so what I've done is I went to calculator.net and statistics calculator. I put this link to the site in the Google Classrooms. So what I did is I took all those numbers from my PowerPoint here and I put them into this box here. Once I've put them all in, I separate them each with a comma. I can hit calculate. And it gives me this list of numbers that I was looking for before, the ones that when we used the graphing calculator, I got all those. So I'm looking for the mean, the median, which is in here, so we're going to have to find that, and the variance, the standard deviation. So I'm going to just take those two things, the mean, 74.2, and my standard deviation of 11.3. Okay, so from that list, I took the mean and the standard deviation, so that gets me them, and I need to find the median, the mode, and the range. So what I'm going to do is write them all in order from least to greatest. Okay, now that I have all the numbers written in order, the median is the middle number. So when I'm looking for that, I'm going to say, okay, this one and this one, until I get to the middle number, which is going to be 78 and 78. So you take the average of them, which is just going to be 78. So I know my median is 78. Now I need to find the mode. So the mode, if you guys remember, is the number that occurs the most. So in this case, 78 occurs 3 times, which is more than any of the other ones that repeat, like 61, which has 2. So my mode is going to be 78 also. And my range is going to be the difference between my first number and my last number. So my first number, or my last number, is 90, and my first number is 54. So 90 minus 54 is what's going to be my range, which is 36. Okay, so according to what those directions just said, if I want to know what this new mean, median, range, mode, all of these things are going to be after adding 12 to each of my numbers, if I already know all the information for this one, that means that what's going to happen is my average, my mean, is going to increase by 12. So I'm going to do my new x bar is going to be 74.2 plus 12, or 86.2. My standard deviation doesn't change. So I'm going to leave my standard deviation as 11.3. My median, my middle number, because we just added 12 to all of them, it's also going to add 12. So my median is going to be 78 plus 12, or 90. All right, and then my mode is now going to be 90 also. And my range doesn't change. It's going to stay 36. Because if I added 12 here and added 12 there, it's still going to be the same distance. So the ones that change when you're adding are the average, the median, and the mode. The range and the standard deviation do not change. Okay? So you guys try this one. Okay, transformations using multiplication. If every value in the set of data is multiplied by a constant k, then the mean, median, mode, range, and standard deviation of a new data set can be found by multiplying each original statistic by k. So here we have a list of numbers, and they want to know what this is going to do if we multiply by 2.5 each of these numbers. So we can start by finding those terms for the list that we have. So I'm going to do the same thing we did last time. I'm just going to write out those things. So the mean Okay, so I've calculated each of these things. The mean is going to be 3.5, so if you take the average of all of those numbers, the median, or the middle number, 12 numbers. So if I cut this in half, 6 on this side and 6 on this side, I'm looking at those two numbers there, and I take the average of them. So 3.3 and 4 gives me 3.5 for the median. My mode is the number that occurs the most, which is going to be 4, because it occurs 3 times. And my range is the difference between 7 and 1 is 6. And the standard deviation I calculated from this data on a statistics calculator. So it's going to be 1.8. All right. So from here, if you want to find what this is going to be, if you multiply each of these numbers by 2.5, what you want to do is multiply each of these numbers by 2.5. So when you're multiplying by a number, everything changes, all of it. Not just the first ones here, the mean, median, and mode, but also the range and standard deviation also change by 2.5. Okay, so that means I'm going to get my numbers to be 3.5 times 2.5. My new mean is going to be 8.75. My median is going to be 8.75. My mode is going to be 10. My range is 15. And my standard deviation is 4.5. All right, so those are transformations of a set of data. You guys figure out what these new mean, median, range, mode, and standard deviation is for this one. Okay, so we want to be able to compare two sets of data using histograms. So in this example, Brittany and Justin are playing a computer game. Their high scores for each game are shown below. Use the graphing calculator to create a histogram for each set of data, then describe the shape of each distribution. So, if you were to use a graphing calculator, this would be what you would get. So, if I'm looking at Brittany's scores, they seem to be symmetric. These are symmetric. Okay, and this one here is positively skewed. Okay. The next part says compare the distributions using either means and standard deviations or the 5-number summaries. Now, because when we did these histograms, one of them was skewed and the other one wasn't, we have to use the 5-number thing. So what I did is I went to the calculator for making a stem and leaf, not a stem and leaf, sorry, a box and whiskers plot. And I want to compare these. So if I'm looking at Brittany's, so this one is Brittany, and down here is Justin. So if I'm looking at Brittany's, her minimum is 29, and his minimum is 26. Whereas they both have the same maximum score. They both scored the highest. They both have the same best score. However, if we're looking at Brittany's overall, she has about half of her scores, right? Because this is the second quartile or the median, right? So half of her scores are better than 43.5, whereas half of his scores are better than 35. So overall, she had more high high scores than he did. So if you want that paragraph form, you can pause this and just analyze what this all says. Okay, so you guys using those calculators that I put in the link for this video, you guys try and figure out this one. Okay, we also want to be able to compare using box and whisker plots. So Steve and Kurt went fishing for the weekend. The weights of the fish they caught are shown below. Use a graphing calculator to create a box and whisker plot for each data set. Then describe the shape of the distribution of each data set. Okay, so if you make these two into box and whisker plots, you would get these two things. So if we want to describe the shape, now both of these, if you look at this one, the bottom one, the distance between these, it's about the same, and the median is pretty much centralized. We're just looking at this part here. If I look at the other one, this one also, they have about the same length of whiskers, and the median is pretty much in the middle of the box. So because of this, these are both symmetric distributions. Okay? The next part says compare the distributions using either the means and standard deviations or the 5-number summaries. Justify your choice. So because they are both symmetric, we can use the mean and standard deviation. So if you were to use those calculators for the ones I sent you in the link that says statistics calculator, and you put in all these data for both of them, you can find the mean and standard deviation. And you would see that the mean weight for Steve's fish is about 2.5 pounds with a standard deviation of 0.8, and the mean weight for Kurt's fish is about 2.7 pounds with a standard deviation of 1. So while the weight for Kurt's fish is greater, the weights of Kurt's fish also have more variability, right? Because this one, Kurt, had a standard deviation of 1, whereas Steve had a standard deviation of 0.8. So Kurt was changing more in weight than Steve's. So this means that the weights for Steve's fish are generally closer to his mean than the weights for Kurt's fish. Okay, you guys, to give this one a go, you can use any of those calculators that I've sent you in the links, or if you have a calculator at home. And that is the end of lesson 12.4.